now?
Okay, go.
Okay, hello. This is group 6. We're going to be talking about our density lab. My name is Sierra.
My name is Nas.
My name is Ali.
And I'm Tommy Wynn.
All right, the first thing I'm going to go over is our 3 points, which is how we calculate volume, density, and the average density, and the rest our teammates gonna take over. So first we I'm gonna explain how we got volume, length times width times height. That's the formula we use to get the volume. We multiplied the length times the width times the height. After that, we divided the number that we got by 1,000 to convert it from millimeters to cubic centimeters. And then we use that as our volume. To calculate our density, we use the mass given over the volume that we got for each point. For the first point, number 1, we got 2.70 as our mass. I'm sorry, as our density. And for the second one, we got 2.72. The third one, we got 2.72 as well. And the fourth one is 2.71. And the way we calculated that average density is we added all 4 densities together and then we divide them all by 4. And our average density is 2.71. And this is our way, this is the way we got the average density and the length and our densities for each point. Next, gonna be for Sierra to talk about.
So for our graph, we used Excel sheets to help build our graph. We used our mass as our y-axis in grams, and then our volume, which we found with length times width times height, as our x-axis, and we added a trend line and the equation of the line to our graph. For slope, we found it as 2.71. And now we'll talk about the average density and the slope and the difference between the two.
Okay, so for the average density, we got is 2.71 gram over milliliter. And for the slope, when we use the Google slide, the slope come out is 2.71 gram per milliliter. And when I calculate it by hand, it comes out 2.732 gram per milliliter. And so I think it's slightly different because when we calculate the density by hand, we have to calculate the volume and then we round is 1. We calculate the density, so it we round it the second time, and then we calculate the average density, we round it the third time. And so I think that's just all about the rounding error in this one, and that makes a difference between the slope and then the average density. And then the sources error, I think in this one, the human error is when we're measuring the height, the width, and the length of the object. We might make a little mistake when we measuring them. And then also for this, it also has a scale error, might be the scale error when we're weighing the object. And Tommy will explain the rest of this.
So yeah, so I'm going to be comparing all 4 of the density values that we got that Ali explained. So for the first one, we got 2.70, second one, 2.72, third one is 2.72 as well, other than the fourth one is 2.71. So we could see that all 4 of them are around the same area, only off by a couple digits. So we could tell by our calculations that we're pretty precise and accurate. And comparing that to the actual known density which is 2.71, we could definitely see that we are right on the money with what we got with the densities. And that brings me to what our percentage error was. When we calculate the average, we got 2.71, which is the same exact thing as the known density of the aluminum. So when we calculate for the percentage error, it's going to be the the known minus the experiment, the absolute value of that number, divided by the known volume. And since it's just 2.71 minus 2.71, which is 0, the percentage error for this experiment was 0%.
Okay, thank you.
Okay.
Thank you.
you.
Thank you.